Hello, today we will present you our Alzheimer's project. This study presents the development of a CNN model for the early detection of Alzheimer's. There is no known cure for Alzheimer's. Most important solutions against this disease is early diagnosis. Available solutions are expensive methods like PET.
Alzheimer's disease affects 50 million people in the world today directly and hundreds of millions more indirectly. In Turkey, it is estimated that there are currently between 600,000 and 1 million Alzheimer's patients, and by 2015, the country is expected to have the fourth highest number of Alzheimer's. In 2015, the global cost of dementia was $818 million and is expected to reach $1 trillion in 2018. There's an article called a CNN-based framework for classification of Alzheimer's, and it proposes a CNN-based framework for the classification of Alzheimer's disease using brain MR scans. The article highlights the advantages of deep learning algorithms over traditional machine learning methods.
There's another article about the field which have used UNet and PET brain images, but as my friend told, it's an expensive method. So in our approach, there are actually 3 steps. Step 1 is data augmentation and solving the class imbalance problem. So we have used oversampling and undersampling methods. One of them is to hinder overfitting, and the other is to hinder underfitting. So step number 2 is transfer learning. We have used pre-trained models, and we have benchmarked the results. We have used DenseNet 169 and ResNet 50 and some other models, but the most successful ones were ResNet 50 and DenseNet 169. We have also used histogram equalization. There are some different methods to process the data, but the most successful one was the histogram equalization. So we have provided an accessible and cost-effective method by the steps I have mentioned. Number 1, data augmentation. Number 2, pre-trained models. We can also tell it transfer learning and histogram equalization for the data processing. So this is the uniqueness of our project.
Original dataset was imbalanced. Data counts was like this. We changed it like this with undersampling and oversampling. As I told you, there was an imbalance in the dataset and dataset was small.
As we can see in the figure, different models were tried and DenseNet 169 was the most successful among them. It was 92.1 out of 100 successful. So there are pros and cons about this project. Our model achieved higher accuracy than the original dataset with data augmentation methods. Different models have been tried, and the best one is DenseNet 169. Since our dataset is small, the success of the model has increased with the transfer learning method. About the cons, since the training stages are very long and we have little chance to try certain parameters, optimal values may not be reached. Some methods were not tried due to insufficient RAM and GPU. And as we can see, thanks to data augmentation, transfer learning, and histogram equalization, an accuracy rate of 92.1 out of 100 was achieved with the DenseNet model. And we can see accuracy, loss, precision, and AUC in these figures.
By effectively employing oversampling, undersampling, transfer learning, and also histogram equalization, we were managed to overcome the inherent challenges in our datasets. We think that Alzheimer's disease will become even more important in future. So by adding advanced CNN models, larger transfer learning datasets, and different undersampling, oversampling methods, it can be even more successful. For our workload, me, Emirhan, Bilgiç was in data adjustment and coding part, Emre was in algorithm and coding, and Alperen was in literature research and also algorithm. So there's a demo for our project. Let me show you. So as I told you, we have tried different pre-trained models in transfer learning. We have tried DenseNet 169, ResNet 50, Inception version 3, and VGG 19. We have also tried VGG 16 kind of structures. And after training the model for 10 epochs, we have managed to reach the accuracy of 94.1, actually, even more than the theoretical value. So we have done some test cases here. For example, for this one, it's a mild demented brain image, as you can see in the path, and the prediction of the model is also mild demented, and the moderate demented file is also predicted as the moderate demented file. So this is a non-demented image, and the prediction is also a non-demented image. And also for the other class, this is very mild demented image, and the prediction is also very mild demented. And thank you for watching.